so much, Year 9. You have behaved impeccably coming into this room. This is the first time that we've attempted a walking talking mock with lower school. It is something that Mr. Hampshire and the teams upper school have been using very, very successfully. In the last English exam, we did a walking talking mock just before the actual exam, and we saw a significant increase in the outcomes for those Year 10 and Year 11 students. So today, a walking talking mock is an opportunity for you to be able to have an expert in the room, in Miss Simmons, who is our numeracy coordinator whole school. She will be taking you through both your numeracy papers that you will be sitting in the summer. Now, obviously not the actual papers, but sample papers, to give you an insight further into how you tackle these questions. It's an opportunity for you to scribble on your papers, to get insights, to think about how you read the question carefully, but also to own this space. This is a space that you're going to be coming in routinely for your examinations over the next few years. It's an opportunity to get a sense of what it feels like to be in this room, to own the space, to succeed in that space. So what I'd like you to all do now is imagine you're coming in, sitting your GCSEs in maths, English, whatever subject it might be, and I want you to take a deep breath, sit up visibly, get the air into your lungs. Know that this is a space that you can succeed, so that you feel empowered. That's the whole point behind it. We're also recording this session, and so this session will be recorded. The school has a YouTube account that is available for students to access walking, talking mocks and other examples of practice papers. So you will be able to watch this at home and look at the tips and the hints that Miss Simmons is going to be able to give you today. So I'm just going to hand over now to Miss Simmons. She's got lots to take you through. Thank you.
Okay, good afternoon. So one of the most important things you need to do is to prepare yourself. Now, I don't mean go home and do hours on hours of revision, though that may be helpful. You need to be organised. And so one of the things I've noticed today is, firstly, the amount of you that don't have a pencil. That isn't what we would expect. We do expect, your form tutors have given you plenty of reminders. You need to be well equipped, not just for tests, but every single lesson. On your desk in front of you, you should have a pen, a pencil, a ruler, a rubber. We're not too worried about the rubber. And most importantly, a calculator. We do not have the equipment to lend to every single one of you. And those of you that have asked for calculators, no, we don't have any. You are to bring your own. If you don't have one, I'm sorry to put it bluntly, but it is just tough. No, you may not use mobile phones as this is an exam, but you are expected to bring your own equipment. This is a mock, so just have a think. How are you feeling? If this was a genuine exam, how would you be feeling if all you've got on your desk is a test paper and nothing to write with? So those of you that have just got your calculators out of your bags, thank you. We will be asking you to put them away for the second part of the test. But we're going to start off with reasoning. Now, it's important that you know these are sample assessment materials, and particularly the reasoning, they are designed to be harder than the usual test papers are likely to be. You've recently done a past paper in maths, so you know the kind of standard. You know that they're not the easiest tests in the world. This one is a bit of a step up, okay? So as usual, I'm going to go through some stimulus materials with you, and the theme for question 1 is blood. So these beings all have blood in common, and you may or may not know that some people have, some creatures may have different coloured blood to what we have. And in fact, there are 5 trillion, that number on the board, 5 trillion, which is 5 million blood cells just within 1 litre of blood. Now, you may know how many litres of blood that you have in your body, but it changes depending on your gender, your height, your weight. For various different reasons, your blood capacity will change. So, as I said, it depends on whether you're male or female and body size. Now, if you were particularly interested to find out how much blood you have in your body, there are a number of online calculators, and you can input your gender, your weight, and your height. And so this is an online calculator, and this woman is estimated to have 3.30 litres of blood in her body. And this gentleman, he's heavier and taller, and he's estimated to have, in the bottom right, 4.66 litres of blood. Many of you may remember it as approximately 8 pints, but it does differ. So, that's all we need to know to be able to answer question 1. Now, I would like you first to fill in all the details. If you haven't done so already, please write your name and your form. And once you've done so, I'd like you to open the page. Question 1 is about what we've just looked at. There's a lot of information to take in on that double page spread, but have a look at it. So I'm now going to take you through how I would approach this question. So, as I said, there's a lot of information to take in, a lot of numbers and so on here. Show how you can work out the formula from the table. That's not use it, it's how could you derive the formula if you weren't given it. So, what I would consider is the fact that we have 2 different heights and we have different weights, and they go up consistently in tens. Now, anything to do with weight and these numbers here, which we're not 100% sure what they are at the moment, I'm going to actually draw a graph, just a little sketch on the side. And I'm going to draw my weight against the volume. And the reason I'm going to do this is because it's going to help me establish a pattern between these numbers, because I need to work out, where do these numbers come from? Where does 0.3 come from? Where does 1.65 come from? So at my 0 kilogram weight, the total volume, which is given here, the total volume of blood is 1.65. So it's actually going to start higher up. It's not going to start at the origin. At 10 kilograms, it's gone up to 1.98 and so on. So if I sketched it all out, it would form a straight line because it's continuous. So this tells me that they go up, well, and I can see for myself, these go up in equal amounts, and they go up in, well, if we just have a look, how do we get from 1.65 to 1.98? So that's an addition. I've added on 0.33. And so that's going to be, well, it's no coincidence, that's that number there. So this is what we would call the gradient, how steep my line is. So I can link this now. If I know about gradients, what else do we know about straight line graphs? Well, we should remember y equals mx plus c. So that's my gradient. So 0.33 is the gradient. We can write that down. And 1.65, where does that come from? Well, actually, that comes from here, which is this value here that we plotted. So if a female was to weigh 0 kilograms, they would have 1.65 litres in theory of blood. So that is my intercept. And then this is just their weight divided by 10. So that forms part of the formula. So we can say, using the line y equals mx plus c with gradient and intercept, as I've written down. And that's how we can work out the formula. That is honestly one of the hardest questions I've seen on a reasoning paper. So if you're still with me, well done. Okay. I'm now going to skip through the rest of this, and I would like you to have a look at the next question, please. So, question number 2. And I'd like you to see how much you can do by yourselves, please. Okay, so apologies if you haven't had enough time to finish, but I'd just like to talk you through this one. Now, again, there's a lot of writing, there's a lot to read, which can be really, really off-putting. So what I like to do is to start by reading the top. So Mount Snowdon is the tallest mountain in Wales. That's great, but is it relevant to what I need to do? So have a look. Well, this part here, match the graphs to the descriptions below. That's what I actually need to do. So I can highlight that if I need to. That tells me what I'm actually doing. So these here are the names of the different climbing routes. So if we have a look at this one, the shortest distance to the top of the mountain, but parts of it are very steep. Well, for us to be able to interpret that, we need to have a look at the graphs. Now, there's a scale, but the axes aren't labelled. However, there is a visual aid, so what I would assume is that these graphs are all from the same starting point perhaps, or a starting point, and we have the height of the mountain going up here, so this, but I'm going to write it here because there's more space. So this would be the height, and this would be how far away it is horizontally from the starting point. So back to this part, it says the shortest distance. to the top. So the shortest distance to the top, that's the key information really. So I'm going to underline that, the shortest distance to the top. So going back to the graphs, where is the top? Well, the top is, I would say, here. And in this case, it's going to be here. So all that flat bit there, that's all the top of the mountain. So as we can see, the top of the mountain for graph B is here, whereas the top of the mountain for graph A is here. So B is a shorter distance to the top because we haven't travelled so far. What about C and D? If we have a look at those, are any further to the left? No, so I would say B is the shortest route, shortest distance to the top, and if we read what else it says, parts of it are very steep. Well, yes, I would say that that is true of graph B, particularly at this point here. This is obviously going to be very steep, and these little bits as well. So my first answer would be B. The next one then starts at the lowest point. So let's have a look at our graphs. Which one starts the lowest? So it has the least height. So A starts very low, it's about 100 metres. B, well, we've already assigned B, but we can still check. B is 400 metres, C is 400 metres, and D, oh, actually D is less than 100 metres. I'd say D is a shorter starting point, a lower starting point, but the end is very difficult. So if we have a look and follow that up to the end, well, yes, this is the end. That's very steep, so it's going to be a difficult route. So my answer to this one would be D. The next one then, the path follows the track of the railway. That's not hugely helpful. It is the longest path. Well, that's useful to know. And the gradient is about the same the whole way through. So that's, you know, there's no big changes in the gradient there. So again, if we have a look, so I'm looking for the longest path. That's the one that ends furthest to the right. So, well, A, I've used D. A definitely finishes further to the right than C. And again, if we compare the gradients, that's fairly consistent, whereas this is quite shallow and then steep. So I would say A. And lastly, it's always best to check, rather than just write in C, we do need to check. It's almost flat for over a third of the way, but becomes rough, steep and rocky. So steep is the helpful word there. So again, if we have a look at C, so it's almost flat for a third of the way, yeah, and it becomes quite steep. Well, that would fit my criteria, so I'm going to write C in there. Oops. So those would be my answers, B, D, A and C. Okay. Right. Lastly, number 3. Have a look through it. And you can attempt this one on your own again. Okay, so we are quite tight on time. So what I'm going to do is to show you my answers. So approximately 89 metres is where Ralph Craig would be. So if he was running the same race as Usain Bolt, then by the time Bolt had finished, then Ralph Craig would only have covered 89 metres of the race. The assumption is that he's travelling at a consistent speed, so from the start to the finish, he's running at the same speed. He isn't getting faster or slower throughout the track. Okay, that's all we're going to have time for on the reasoning paper. Lots of you I can see are copying this down. Please don't feel the need to do that. You can take your papers home and you can have the time then to spend on those questions if you wish to, and we will upload the mark scheme to this onto the school website so that you can check your answers after you've had a fair chance to look through them properly. So what I need you to do now, please, is pop your calculators on the floor underneath your desks. And I would like you to do a swap, so your reasoning paper that you've just done, if you can swap it for the procedures paper that is underneath your desk. If you haven't got one there yet, there soon will be. But if you can pop your reasoning paper underneath your desk, please, because you don't need that anymore. Can you please put your name and form on this paper? And you can open your papers. So question 1 is asking us 37 plus something is 1002. Now I would personally count onwards. Now some of you may do it using subtraction, so this method, and if that works for you, that's great. The main issue I would see with this is that we've got lots of zeros, so we might have to borrow a fair bit. If we did it on a number line instead, starting at 37, and we want to get to 1002. Sorry, I just crossed that out so it's not in the way. 37, if we jump up in the tens and hundreds and so on, so 37, after that goes to 40. The next 100 on from that is 100, and then we've got 1000 here. And we can see how much we've jumped. So from 37 to 40 is 3. 40 to 100 is 60. 100 to 1000 is 900. And, sorry, I should have gone all the way there. And 1000 to 1002 is just 2. And that's how far I've gone. So now all I need to do is add them up. So 963 and 2, and that's going to give me 965. So 965. Now, like I said, you can use whichever method you prefer, but the counting forward one is quite nice. Okay, I'd now like you to have a look at question 3. So just have a read through of it in your own time. You can start making notes, you can approach the answer if you like. So the first thing that strikes me, we've got 1 hour and 30 minutes. That's a time. And we're driving 63 miles, which is a distance. And we're being asked average speed. So anything to do with time, distance and speed, we need to know the formula to use. Now, some of you may have learnt the formula in science, or you may use triangle, formula pyramids, and I know that. So if you haven't come across that before, how it works is you cover what you're trying to work out. So I'm trying to work out speed, so speed being the S, so I cover the S, and that leaves me with D over T. So I know that speed equals distance divided by time. Now, the distance is easy, that's 63 miles, but the time is a little bit harder because 1 hour 30 minutes, it's different, it's not a normal number. Now, I could convert it to 90 minutes if I wanted to, but if I look at the answer box, it clearly says miles per hour, so turning it into minutes isn't going to be helpful. So I really want to keep it in hours, so 1 hour 30 minutes, if I put that into an hour, that's going to be 30 minutes is half an hour, and a half is 5.5. Okay, don't make the mistake of writing 0.3. So 63 divided by 1.5. Now this is a non-calculator paper, so that's quite a difficult calculation. It's not one that I'm confident that I can do, so I'm going to change it. It's a division, but a division is the same as a fraction. So I could put an equivalent fraction in here. So that is equivalent to what? Well, you might decide to multiply top and bottom by 10, so you could have 630 divided by 15. That could work. Or if you wanted to keep your numbers smaller, like I do, 1.5 or 0.5, if I double it, that's going to turn it into a whole number. So I'm going to double both top and bottom. So that's 126 divided by 3. And again, as a fraction like that, I'm not quite sure that I can do it. It's not something that I'm familiar with, that I know off the top of my head. So I'm going to use short division. Some of you may prefer calling it the bus stop method. So 126 divided by 3. And so I can go 3 into 1. It doesn't go. You may record your 0, you may not. 3 into 12, well that does go. That goes exactly 4 times, no remainder. And 3 into 6 goes twice. So, well, that's a lot easier. So it's just 42 miles per hour. A lot of work there, and it's only 2 marks. But the fact that it is worth 2 marks tells me I'm going to have to do a few steps. Not necessarily 2, it might be, a few different steps. Okay, so I would now like you to have a go, please, at question 9 and 10. Okay, so 3 cubed, this little 3 is a cubed. That means we've got 3 of them, so that's actually 3 times 3 times 3. And if I work that out, 3 times 3 times 3 is 27. This one is 3 squared, so that's 3 times 3, which is 9. Okay, a lot of people make the mistake of 3 squared is 6, but squared means times itself. We don't times it by the power, we times it by itself that number of times. And then 27, take away 9, gives me 18. And then bearings. So what is the bearing of A from B? Well, from B, that means I'm here, and I want to get to A. But I know with bearings, I have to go clockwise from north. So clockwise from north until I get to A, that's that angle there. So I need to calculate that angle there. I haven't been asked to bring a protractor, and I haven't got one, but that's fine, because actually it would tell me to measure. If I needed my protractor, it would say measure, and it doesn't say measure, it asks me what it is. So I know, because it doesn't say measure, I have to work it out. Now, angles in parallel lines, north is always parallel to north, so I know that these two angles are supplementary. They form like a C, like that, and so the internal angles on a C are supplementary. That means they add up to 180. So this angle here is 180 minus 130, which is 50 degrees. So now I can work out this angle, the bearing A from B. Well, angles around a point add up to 360. So I've got my 50, so if I subtract my 50, that's going to be 310 degrees. So my answer in the box is 310 degrees. Okay. And lastly, I would like you to have a look at question 14, please. Take a minute, have a think, what are you going to do? How are you going to do that? So this is a division, and there are so many different ways you can divide. If you're not sure, then my maths lists quite a lot of different methods, and it's very good for division. There's things such as chunking, or there's long division, and I know that a lot of people fear that. It's not something that I particularly would use, as I don't see that it's necessary. I think that the bus stop method I showed you earlier is perfectly sufficient for any kind of division you're going to need, even though these numbers are large. So we're dividing by 27. Now on the last example we were dividing by a single digit number, and that was fine, because I knew that times table. I don't know my 27 times table, but if I did, it would be quite useful to this calculation. So what I'm going to do is I'm actually going to write out the multiples of 27, because that helps when dividing. So 27, so if I add 27 onto that, or double it, that's going to give me 54. And you can write this down here if you need to. If you need to physically work it out, that's fine. 54 plus 27, So that's going to give me 81. If I add on another 27, that's 108. And I'm just going to leave it there. I'm not going to go any further because 3 digits I hopefully won't need to divide by any more than that. And then I'm going to set it out as a short division. So 27 goes into 8, no times, it doesn't go. 27 goes into 86, well now I've got it all in front of me. I don't have to think, oh, 27, 54. I've got it all there. It's already worked out for me here. So into 86 it goes once, twice, 3 times. It doesn't go in 4 times, so it goes in 3. With remainder, well, the difference is 5. 27 goes into 56. 1, 2, just twice. And the difference between 54 and 56 is 2, so the remainder is 2. And now 27 into 27, well, that's nice and easy, it's just 1. So my answer is 321. And that's it. Okay. Right. What I would like you to do, please, I would like you to just very quickly have a look through the paper. Don't attempt the questions, just have a look at them, please. Now, as I said earlier, these are sample materials, so they're not actually as long as the real tests will be. The questions are of the same level of difficulty. Like I said, the reasoning one I do think is a bit harder than you would normally see. What we're going to do is we're going to ask you to take these home. We're not going to collect in the papers, so both of them, the procedures and the reasoning, we would like you to take home. You can put them in your bags in a minute, please. Have a look in your own time, whether it's individually or maybe a few of you have a look at them together. Do have a look at them. There's lots of questions, far too many for us to have time to attempt today. So have a look through them and give them a go. If you wanted help with them, come and find your maths teacher or me. If you need any help, obviously that's fine. We're happy to provide you that help. You can always come on a Tuesday or a Thursday after school if you wanted. If you just wanted to sit there working through it, that's fine. But this is to build your confidence. This is so that when you're sat here with me in 2 weeks' time, you think, yeah, we've done this. I remember, I saw it on the board, I can do it. Okay, and that's the purpose. Don't be scared by what you've seen today. As Mrs. Gardner said, be empowered by it. This is all for your confidence. Okay? Miss, do you have anything before they go?
So thank you so much, Year 9. You've listened incredibly well. Now, when you come back after your lunch, you're going to be coming back and sitting in the same seats as you did before. We'll be asking you to come in from the same entrances as you did. And in a moment, I'm going to dismiss you row by row so that you can go over and get your lunch. Can I just ask you to be really prompt? Because Mr. Jones, the subject leader for English, will then be taking you through the literacy paper in the same way that Ms. Simmons has been taking you through the numeracy paper. I hope you found it useful. I would encourage you all to attempt these questions, to talk to your maths teachers about them. Please don't touch your papers at the moment, can I see people shuffling, so that you can maximise the use out of these sessions. I'm going to start with the 2 extremes, if I may. So you can leave things, as long as they're not valuables, you may leave your pencil cases and you may leave your materials here because you'll be coming back here afterwards. Can I ask for the 2 extremes to stand up, to tuck your chairs under? Can I ask staff to open the doors so that they can leave properly from those 2 sides? sort of the working out questions worked out really well.
Yes.
Yeah, I thought it was really good. I thought you were so clear. It was brilliant. Well, we can't because we're doing this. Yeah.